Hi, I'm Paul Kyogan from Gktuition, and in this video I want to talk to you about patterns. Now the question I'm going through here is 2018 Paper 1 Question 4. In the first part of this question you're given the first three patterns of a sequence, or the first three terms, and you're asked to draw the next one. So you should recognize that the first one, the shaded boxes, is 2 by 2, the next one is 3 by 3, the third one is 4 by 4, so the one you have to draw is 5 by 5. That one is just 5 by 5, and then you have your clear box up here and your clear box down here. And that's what the marks are going for the first part. For part B of this question, it says, based on the pattern, fill in this table. Now you'll notice I filled in most of it because we already have most of it. I know the first one, the greys are 4, then 9, then 16, then 25. There's always two white ones. So I know the fifth one is going to have two white ones as well. Now you need to recognize the pattern that the grey ones here were 2 by 2, 3 by 3, 4 by 4, 5 by 5. Obviously the next one is going to be 6 by 6, which is 36. In the next pattern there would be 6 by 6, so there'd be 36 of those. Then 36 and 2 means that there would have been 38 in total. So that's what you're getting the marks for there. Okay, so for part C here, it tells me that the pattern can be described by the formula Tn equals n squared plus bn plus c. And it asks me to find the value of b and the value of c. Now you should recognize here that you're looking for two unknowns. You need to find b, you need to find c. If you're trying to find the value of two unknowns, that means it must be a simultaneous equation. If you're going to do a simultaneous equation, you're going to have to come up with two different equations. So I can come up with an equation based on the fact that the first term is equal to 6. We're talking about the total here, so I know that the first term is equal to 6. In other words, I could write that as T1 is equal to 6. Which means that if I sub in a 1 instead of an n, I can let the whole thing equal to 6. So supposing I'm just subbing into the general formula they've given me. Instead of n squared, it's 1 squared plus b times 1 plus c. I know that when I sub in 1, it will be equal to the total number in the first term, which is 6. So in this case, this is going to be a simultaneous equation. So I'm going to set this up. I'm going to bring all my numbers to one side. I'll leave all my letters on the left, just so I'm ready for my simultaneous. 1 squared is 1 plus b plus c equals 6. You're going to bring your 1 to the other side, and you're going to subtract 1 from both sides, so it becomes 6 minus 1. So my first equation is that b plus c is equal to 5. That's my first equation in what will be a simultaneous equation. So now I need to come up with a second equation. In order to come up with a second equation, I can use the fact that the second term is equal to 11. So if I do the same thing, I can now say that, right, well, T2 is equal to 11. That means I'm subbing into Tn again, but everywhere there's an n, I'm going to sub in a 2. And if I do that, I can let the whole thing equal to 11. So this will become, instead of n squared, it becomes 2 squared plus b times, instead of n, it's a 2 plus c equals 11. So you get 2 squared plus b times 2 plus c equals 11. 2 squared is equal to 4 plus 2b plus c equals 11. If I subtract 4 from both sides, I end up with 2b plus c equals 11 minus 4. So 2b plus c is equal to 7. So my second equation is 2b plus c equals 7. If you now look at the two that I've highlighted, this is just a very basic simultaneous equation. It'll be relatively straightforward for me to find the value of b and to find the value of c. Okay, so remember my goal here is to find the value of b and to find the value of c. I now have two very simple equations with b and c in them. So if I do a simultaneous equation, I'll be able to find the value of b and the value of c. In this case, I'm going to try and get rid of my c's. And since there's a plus c on the bottom, I'm going to try and turn the tops into a minus c. If I multiply the top line by minus 1, I'll have minus c, and the c's will cancel. So if you multiply everything on the top by minus 1, you'll get minus b minus c equals minus 5. The bottom line is going to stay the exact same because I'm going to do nothing with it. Now I'm just going to add my two lines together. 2b minus 1b is just b. Plus c minus c is 0. And 7 minus 5 is 2. So without doing any more work, I already know that b is equal to 2. Once I know the value of b, I can sub into one of my original equations, find the value of c. So I'm going to take the easier one. The simpler one is b plus c equals 5. And instead of a b, I can sub in a 2. I can say that 2 plus c equals 5. So if I subtract 2 from both sides, I get c is equal to 5 minus 2, so c is equal to 3. So I also now know my c. Now, the question was, I told you the general formula was n squared plus bn plus c. So you should really sub in at the very end. You should say that Tn now is n squared, and instead of Bn, I can write it as 2 times n. Instead of c, I can write it as 3. So it's n squared plus 2n plus 3. And that's your final answer for that bit. Okay, so I know the formula to calculate the number of tiles is n squared plus 2n plus 3. And they've now told me, they've asked me to figure out which pattern will have 443 tiles. So I just have to let n squared plus 2n plus 3 equal to 443. And when I do that, now you should realize you have an n squared, you have an n, and you have a number, which means that you have a quadratic equation. So that means you're going to bring everything to one side and you're going to try and factorize it. So it's n squared plus 2n plus 3 minus 443 equals 0. Which means if you simplify this fully, you get n squared plus 2n minus 440 equals 0. Now if there's a minus at the end, you need to use the factors, numbers that multiply to give you 440 and have a difference of 2. So if you use trial and error in your calculator here, you'll eventually get to 22 multiplied by 20. 22 multiplied by 20 is 440. And it has a difference of 2. So in this case, I want them to add up to plus 2, which means it's going to be plus 22 minus 20. Now I can just write out the factors of this quadratic. The factors of n squared are n multiplied by n. The factors of minus 440 that I'm going to use are plus 22 and minus 20. So I know that n plus 22 times n minus 20 would give me this. They're your factors, but obviously now you need to solve it. In order to solve it, you can let each one equal to 0. So you can say n plus 22 equals 0, and you can say n minus 20 equals 0. If n plus 22 equals 0, you bring the 22 to the other side and it becomes negative. That means that n is equal to minus 22. Or you bring the minus 20 and it becomes n is equal to 20. Now remember, you're trying to figure out which stage in this pattern will have 443 terms. It doesn't make sense to say that the minus 22nd pattern will have 443 tiles. So that answer doesn't make sense. So the valid answer here is 20. If you had written out the first 20 patterns in this sequence, the 20th one would have had 443 tiles. So I hope that makes sense. If there's anything you're struggling with there, make sure you let me know in class or send me an email and I'll try and clarify for you.